This next chapter that we're going to get in is oxidation reduction. And before we go over the definition and how to figure it out, you have to learn how to find the oxidation states of compounds. So that's the first thing we're going to do, learning how to do oxidation states of compounds. Now, one of the easiest things is if the metal only has one oxidation state, it's pretty easy to figure out all the oxidation states of the rest of the elements. But if the metal has more than one oxidation state, it's a little bit more difficult. So here we go. So K2CrO4. That metal, if you look on the charts in group 1, it's got a +1 oxidation state. But since there's 2 of them, the total would be +2. Now, we don't know what chromium is. It's got a couple oxidation states, but we know what oxygen is. -2. And that's 4 times a -2. That's a -8. So I've got a +2 and a -8. Chromium should be a +6. But what you have to do is you have to look at your periodic table to make sure chromium has a +6 oxidation state. So when we look at the periodic table, there is chromium right here. And as you see, chromium has a +6 oxidation state. So that one is well done. Okay, let's go to the next one. HClO. Chlorine's got a ton of oxidation states, but hydrogen's going to be a +1. Oxygen's going to be a -2. So a +1 and a -2, that means chlorine can only be a +1. So that whole thing equals 0, but let's make sure. And here's chlorine, and chlorine does have a +1. So that's how you know that it's correct. MgSO4. Magnesium's in group 2, can only have a +2 oxidation state. O, -2, that total is a -8. So I have a +2 and a -8 to equal 0. Sulfur's got to be a +6. So we better check it out to make sure it is. Does sulfur have a +6? Yes, right there. Sulfur has a +6, so that's good. FeCO3. Here's a problem. Iron can be this, a +2 or a +3. So it has multiple oxidation states because it's a transition metal. So how in the world do you figure out what oxidation state iron will be? You got to look and see what it's hooked to. Okay? So what it's hooked to is it's hooked to carbonate. And carbonate is a polyatomic ion that has a -2 total charge. So if carbonate has a -2 total charge, then iron has to be a +2. And that equals 0. But what about the C and the O3? Well, we know that iron is a +2. We know that oxygen is a -2. And 3 times -2 is a -6. So we have a +2 and a -6. Well, that means carbon must be a +4. So what we're going to do is we're going to make sure carbon is right there, and there's a +4 right there. Okay? All right, so those are the hard ones when the metal has more than one oxidation state. NO, well, N's got like a ton of oxidation states. O usually has just one, so that's a -2. And so if O is a -2, N's got to be a +2. So that was an easy one. Number 6. Let's go NO2. So again, N's got a ton of charges. O can be a -2. I have 2 of them, so that's a -4. So N's got to be a +4. Okay? Number 7. This is a polyatomic ion. So this is a little bit different than all the rest. PO4 minus 3. So why is this different? Because the charges will not equal up to 0 like normal compounds. The charges, or the oxidation states, have to equal up to whatever the charge is on the polyatomic ion. So we have this. We got P and we got O4. So O is a minus 2. 4 times minus 2 is minus 8. So what plus a minus 8 will give us a minus 3? Well, it's going to be a plus 5. So plus 5 and a minus 8 will give us a minus 3. But we better make sure that phosphorus has a plus 5. So there's phosphorus and there's the plus 5. So we're good on that. So don't forget, polyatomic ions have to equal whatever their charge says it has to equal. So this is a pretty long one. So Al2S2O3. Now, let's just see. Aluminum is in group 13. It can only have one charge. That's a plus 3. So that means that is a plus 6. O is a minus 2. And that would be 3 times 3 is 9 times a minus 2 would be a minus 18. And then plus 6 and minus 18. The S has to be a plus 12. But look at how many S's. 2 times 3, we got 6 S's that have a total of plus 12. So S should be a plus 2. So let's see if that works. S, if you look, it does not have a plus 2. It's got a minus 2, plus 4, and a plus 6. So that compound we just did probably won't be on any test or anything, since the sulfur's oxidation state is not on the reference table. Okay? All right, next one. This is number 9, and these are all weird ones. OF2. Now, like I said before, oxygen's oxidation state 99% of the time is a minus 2. Unless it's a diatomic gas, then it would be neutral. But when it's combined with fluorine, fluorine has this charge, minus 1. And since there's 2 fluorines, that's a minus 2. And if that's a minus 2, oxygen has to be this, a plus 2. And that's so weird because, like I said, 99% of the time oxygen's a minus 2. And this is one of the only examples you need to know that oxygen has a plus 2 oxidation state. So this is a very odd one right here, OF2. All right, next one. Number 10, H2O2. Once again, this is way different. And I don't really like to give my students this on a test because it's so weird. So I know that H is a plus 1 and its total is a plus 2. So how can 2 oxygens, they have to be a total of minus 2 to equal 0. So that means each oxygen has to be a minus 1. And that's when oxygen is a minus 1, and that's when oxygen is a peroxide. So this is hydrogen peroxide. And this O2 minus 1, that is the peroxide, and that's a polyatomic ion. So that's very difficult for students to figure out. Okay? Okay, now, number 11. MgH2. Well, that's kind of easy. Mg's in group 2, only one oxidation state, that's a +2. Now, hydrogen is usually +1, or if it's a diatomic gas, it's neutral. But here, what's happening is hydrogen has to be a -1, and that'll give us -2. So in this case, this is called a metallic hydride. And it's very interesting because hydrogen can steal electrons from only group 1 or 2 metals. And it's going to be a negative charge. So like this, NaH, Na is a +1, H is a -1. This is from group 1, this is from group 2. That is called a metallic hydride. So, let's go over the two really important elements that have a couple different charges. Oxygen, number 1. If it's a diatomic gas like the air we're breathing, O2 has to be neutral. So that's the first one. Number 2. O in almost every single case, unless it's a diatomic gas, is this, -2. Almost always. Now, number 3. If it's hooked up with 2 fluorines, like I said, like we did before, it's a +2. That's the only time that we know in high school chemistry that oxygen is a +2. Number 4, H2O2 or Na2O2. The oxygen in both cases, O is a -1 charge, and that's a peroxide. So the 4 charges for oxygen, neutral if it's diatomic, -2 almost always, +2 if it's with fluorine, and if it's a peroxide, it's a -1. All right, now let's do hydrogen. Hydrogen, number 1, if it's a diatomic gas, all diatomic gases are neutral. Okay, number 2, most of the time hydrogen has a +1 charge. Number 3, if it's hooked to a group 1 or group 2 metal, it's going to have a -1 charge. Remember, group 1 or group 2 metal, that's it. It can't rip off any other metals other than group 1 or group 2. So hydrogen, neutral, +1, and a -1. Let's do a few more finding oxidation states, and then we will get into the definition of oxidation and the definition of reduction. Okay? All right, how about this one? N2O. Well, we know nitrogen has about 5 or 6 oxidation states. O, if it's not hooked to fluorine or diatomic gas or peroxide, is always -2. So that's a -2. Well, this means I have to have 2 N's. They both have to be +1. But let's check out and see if nitrogen has a +1. There's nitrogen right there, and there's the +1. So that is a viable substance. All right. The next one is going, so this is HClO3, H +1, oxygen -2 for a total of -6. So a +1 and -6, chlorine should be a +5 to equal 0. So let's see if chlorine has a +5. There's chlorine, and yes it does, it's got a +5. Okay? All right. Let's do one more. PbO2. Lead's got, I think, 2 oxidation states. We have to figure out which one it is. Oxygen, you know that's a -2 for a total of -4. So if that's a -4 and I only have one lead, that lead should be a +4. So let's see if lead has a +4. There's lead right there, and there's a +4 right there. So, all right, here's a few more finding oxidation states. So we're going to find the oxidation states of all this. Remember, all the oxidation states have to equal a 0. So, K. H is a +1, but we have 2 of them, so that's +2. O almost always is a -2, so 3 times a -2 is a -6. So we have +1 and +2, that's +3, and a -6. Phosphorus must be a +3. So let's see if that's true. Here's phosphorus right here, and that's a +3, so that works. So let's do MnO2. O -2, total -4, so Mn must be a +4. So the name of this would be manganese Roman numeral 4 oxide. So let's find all the charges in this one. H +1, total on top is a +2. O -2, total on top is a -6. +2 -6, this has to be a +4. So let's check it out. There is carbon right there, and there's a +4, so that works. The first thing about this is gold can be this, a +1 or a +3. So we have to figure out which one gold is. And remember before I told you if the metal has more than one charge, see what it's hooked to. Well, it's hooked to sulfate, and sulfate has a -2 charge. And there's 3 of them. So we have a total of -6 there. Gold, we have 2 of them. So how are we going to get a +6 to equal 0? Well, we're going to have to use this one right here. So this is a +3. So 2 times a +3 is a +6. A +6 and a -6, that equals 0. So we know gold is a +6, a +3, and there's 2 of them. So let's see if we can find sulfur and oxygen. Well, we know oxygen is a -2, and that would be 3 times 4 is 12, times 2 is 24, a -24 there. And we already know that gold is a +6. So what we have is sulfur. Total sulfur has to be +18. Now, obviously, sulfur doesn't have a +18, but we have to remember there are 3 sulfurs. So each sulfur should be a +6. So let's see if there's a +6 for sulfur. There's sulfur, and there is a +6. So we're good with that. So now the name of this crazy thing would be gold, Roman numeral 3, sulfate. And that's a very, very difficult one. So we're going to do one more. So we're going to do one more, and it's this one. So we have to figure out, does copper have more than one charge? Yes, copper does have more than one charge. Here are your choices. +1 and +2. One of those has to be copper. So how do you figure it out? You see what it's hooked to. Well, it's hooked to this. And that is a -2. So if that's a -2, how do we make copper a +2? We have 2 of them. My students always get this one wrong. Copper is not a +2 because I have 2 coppers. So copper must be this one. Copper must be a +1. So this name would be copper Roman numeral 1 chromate. Copper Roman numeral 1 chromate. Now let's see if we can find what Cr's charge is. So this is a +2 total above the copper. This is a -2, -8. So I have a +2 and a -8. That must mean chromium should have a +6. Let's check it out and see. And there it is, chromium, and that has a +6 right there. So it does work. So the name of this, once again, would be copper Roman numeral 1 chromate. That's a hard one.